Yeah, so I'm going to start with number one. And this is question number one. The question is two events, M and N. Hope you can all see my screen. Two events, M and N, are such that the probability of M happening is 0.7. The probability of M and N happening is 0.45. Probability of M complement intersection N complement is 0.18. And I've been asked to find probability N complement. Okay. And the probability of M or N, but not M and N. So, what is the probability of N complement? The probability of N complement, I hope you can all hear me. If you can't hear me, please say so that I know. Um, okay, the probability of N complement is 1 minus the probability of N, because the probability of N complement is N not happening. And so it's just 1 minus the probability of N. So you could choose to find the probability of N first and then subtract it from 1. Or you could be a little creative if you can actually get the probability of N complement without having to first find the probability of N. Let's examine at least two methods. So first, you could start by saying that the probability of N complement is, in fact, the probability of M intersection N complement plus the probability of M complement intersection N complement. Why is this true? This is true because just by saying it, the probability of N not happening is the sum of the probabilities when it happens with M and when it happens without M. So N not happening can either happen with M or it can happen without M. And these two sets, M intersection N complement and M complement intersection N complement, are two disjoint sets. And so their union is in fact N complement and is the sum of the two. The probability of the union is the sum of the two probabilities because they don't have an intersection. These two sets, this set and this set, don't have an intersection. Some of you might be familiar with a table that looks like this. And so here you have M intersection N, M complement intersection N, M intersection N complement, and then M complement intersection N complement. Yeah, it's called a contingency table. And this table shows us that the probability of N complement is in fact the sum of these two probabilities, which is what we have here. And the question gives us the second one, but it doesn't give us the first one. So how do we get the first one? How do we get M intersection N complement? Then you look at this column. Because by looking at this column, you can see that M intersection N complement is in fact the probability of M minus the probability of M intersection N. And this makes sense when you think about it, because the probability of M not happening with N is the probability of M minus the probability of M when it happens with N, which means what is left must be the probability of M when it doesn't happen with N. Yeah. So, sorry. So once we're at that step, we really already have exactly what we need because all those probabilities are given to us in the question. So it'll be 0.7 minus 0.45 plus 0.18. And when you work this out, you should get 0.43. I hope that's clear. So alternatively, like I said, you could decide first find the probability of n, and the probability of n is okay, now if you decide to use the contingency table, it might get a little complicated because you see you have to get you have to get m complement. So that's a little tricky. So the other equation that you could use is the fact that the probability of n plus the probability of m minus the probability of m intersection n is in fact equal to the probability of the union of the two sets. This is a known equation, but it stems from the fact that if I was just draw a simple Venn diagram, stems from the fact that if these are your two sets, m and n, if you add set n and set m, you realize that you're counting the intersection twice. Yeah. And because we want to count every portion once, you subtract the intersection once, so that you also count it exactly once. Because if you just add the two sets without subtracting the intersection, then you've double counted the intersection. So we have to subtract it once to get the union. But you realize that the union is the complement of this outer part. Yeah, this outer part. And the outer part is m complement intersection n complement. So this equation could also lead you to get the same answer. You realize that if you actually rearrange this equation to get what we want, remember what we want is probability of n complement, which is 1 minus probability of n. So you could take the p of n to the right and bring everything else to the left. You'll end up with probability of m minus the probability of m intersection n plus the probability of m complement intersection n complement. And realize that that's exactly what we have right here. So you should get the same answer. Let's go to part B now. Let's go to part B now. So part B is asking us for the probability of m or n, but not m and n. So you need to be able to interpret this in terms of these four sets here. What among those four sets do they want? M or n, but m and not n. So that means m or n, just m or n alone, is in fact the union of the two sets. Probability of m, union n, but not m and n, so that means not the intersection. Yeah. So you don't want the intersection involved. So if you look at these four sets, which of these four sets actually give us what we want? And you realize that they want us to have, when m happens, it happens without n. And if n happens without m. So this is actually what the question wants from us. M or n, but not m and n. Now, to get this, you could say that it is exactly 1 minus the other two remaining sets, because the sum of these four sets, the sum of the probabilities of these four sets is 1, because they are all disjoint and they actually encompass all the cases. They are exhaustive and mutually exclusive, actually. So the sum of their probabilities is 1. So you could say that it's 1 minus the probability of m intersection n plus m complement intersection n complement. And if you actually think about it, this is m and n, which is not wanted, and this is not m and not n. Yeah, so it's also not wanted. And not to get the probability of a set you want, you can get the probability of the complement and then subtract it from one, which is what we are doing. Um, I'll take the question after I'm done, yeah? So let me first finish, and then Cynthia, you can come in with your question. Um, this is 0.18, and so this will give you 0.37. Yeah. However, you could do this in another way, yeah? There's more than one way to get this answer. You could actually get M intersection N complement, which like we saw from this part is equal to probability of M minus probability of M intersection N, and that should give you 0.25. You could also get M complement intersection N. How would you do this? You could use the probability of N. Yeah, you could use the probability of N and then subtract the intersection of M intersection N to give you that. So that looks like 0.7 minus 0.45, then plus the probability of N, remember, is 1 minus the probability of N intersection, sorry, minus the probability of N complement. So that's 1 minus 0.43. But then we're subtracting the intersection, which is 0.45. This will give you 0.25 plus 0.12, which is also equal to 0.37. Yeah, so this is question one. Cynthia, you can ask your question. Okay, any other questions? Same Cynthia has failed to ask us. Any questions on this question, or should we move to number two? It seems there's a question.
Excuse me.
Yes, please.
On part B, when you said 1 minus P into brackets M intersection N, were you
Yeah.
subtracting, since you said that when you get the union, or when you're getting M or N, you shade the intersection twice. So were you subtracting that one from the intersection so you can get M as a whole and N as a whole? Or you wanted to
Okay.
get M only and N?
Okay, so I'll try to illustrate this using a Venn diagram. We want to get M only and N only. That's what the question actually asks. M or N, but not M and N. If I use this the Venn diagram that I drew, the sets wanted in this particular case are this one and this one, right? So that means the unwanted sets are this one and this one. Now, total probability is always one. So that's where the one is coming from, Cynthia. Like total probability is always one. So if I have, this is the basic principle. The basic principle is that for any event, probability of A is always 1 minus the probability of its complement, because an event either happens or it doesn't happen. Yeah, so that means that the sum of it happening and it not happening, the sum of those two probabilities should give you a 1, because one means that's a sure event. And I can say tomorrow it will either rain or it won't rain, but like one of the two has to happen. Or I could say money will either lose or it will not lose. Yeah. But like one of the two has to happen. So if we're being asked for M only and N only, I can get M intersection N and M complement intersection N complement, add the two and then subtract them from one, because one is the total probability of of an event and the probability of an event and the probability of its complement. So that's where the one minus that comes from. I hope that makes sense.
Thank you. Yes.
Okay. Okay. If there are no other questions, I'll move on to question 2. Yeah, so question 2 uses what we call, okay, it encompasses conditional probability. Yeah. So some of you may not have learned about conditional probability, so I'll just give a brief preamble. When you see that symbol, slash, it really just means this, and it's read as A given B. So probability of A given B is 0.4, probability of B given A is 0.25, probability of A union B is 0.12. Let us find the probability of A union B complement. Now, A given B simply means the probability of A happening given that B is going to happen. And it's computed by the intersection of A and B divided by the probability of B. This makes sense if you think about it, but it may not make sense straight away. But if you don't understand, then you can just take the formula at this point, because getting into that right now would take a lot of time. And similarly, of course, for this particular question, the probability of B given A means the probability of B intersection A, which is the same as the intersection B, but this is divided by the probability of A. Now, if this is 0.4, yeah, if this is 0.4, this means that the probability of B is equal to the probability of A intersection B divided by 0.4. But dividing by 0.4 is the same as multiplying by 5 over 2, since 0.4 is 2 over 5. So this actually becomes 2.5 times the probability of A intersection B. Similarly, if this is 0.25, this implies that the probability of A is probability of A intersection B divided by 0.25. And dividing by 0.25 is the same as multiplying by 4. So that's exactly that. Okay. What do we want? We want to find the probability of A union B complement. Now, you could write this on the side that the probability of A union B complement is probability of A plus the probability of B complement minus the probability of the intersection of the two sets. This is standard, works for every like how we this it's exactly this here. It's just that one of the sets is a complement, but the union of two sets is always given by the sum of the two sets minus their intersection. The probability of the union, or the number of members in the union, is the sum of the probabilities of the two sets minus the probability of intersection, or the number of members in the two sets minus the number of members in the intersection, because you don't want to count the intersection twice. So that applies also to a set with maybe even the complement of another set, because the complement of another set is just another set. Yeah, so that means we need the probability of A, we need the probability of A, we need the probability of B complement, and we need the probability of A intersection B complement. So these are things we have at the back of our mind while approaching this question. Someone has asked me for an example of conditional probability. Question 3 tells us that the probability that a fisherman catches fish on a clear day is 2 out of 5. So what does that mean? It means that if it's a clear day, yeah, then the probability that he catches fish on that day is 2 out of 5. So that's like saying the probability that he catches given a clear day is 2 out of 5. We'll get into this question more, but I'll just give you an example of conditional probability. So there it's saying that he'll catch fish given that it's a clear day, because it's not guaranteed that it will always be a clear day. That also has a probability of its own, as you'll see. Yeah, it also has a probability of its own. But if it's a clear day, the chance that he'll catch fish is actually 2 out of 5. So that's what conditional probability looks like. That if something is going to happen, there's something that depends on it. So what's the chance of that thing happening? Yeah. For example, what's the chance of sorry, I like football a lot, so my examples might be skewed towards that. But what's the chance of Chelsea winning, the Conference League if Anthony is not going to play? For example, something like that. So you're looking at conditions that might affect the probabilities of other things. Yeah, so that's basically what conditional probability looks like. So now realize that we've managed to express probability of B, the probability of A in terms of A intersection B. And that's very important because probability of A union B is probability of A plus the probability of B minus the probability of the intersection. And this is given to us in the question as 0.12. Yeah, but we know that the probability of A is 4 times the probability of the intersection. The probability of B is 2.5 times the probability of the intersection. And then we just have, minus the probability of the intersection. And this is 0.12. If you simplify that, you end up with 5.5 times the probability of the intersection being equal to 0.12. That means that the probability of the intersection of A and B is 0.12 divided by 5.5. Now, when you simplify this, this is 6 out of 275. I prefer to keep them in the simplest form of the fraction. Remember, what we want is probability of A union B complement. That means we need A, B complement, and A intersection B complement. So now, first of all, we can get from this, we can get the probability of A. The probability of A, we said, is 4 times the probability of intersection. So it's going to be 24 out of 275. We need B complement, but we can first find B. Probability of B is 2.5 times this, which is 15 over 275. Now yeah, I'm so sorry about that. Since my network was a bit shaky, but I hope you can see my screen again, and I hope you can hear me clearly. Okay, so like I was saying, probability of B is 2.5 times the probability of the intersection, which is 15 over 275. Now we can reduce this, but I'm just going to keep it out of 275 because everything else is out of 275. So for simplicity, I'm not going to reduce this, but if you want to, you can divide through by 5. By 5, you should get 3 out of 55. Remember, we want the probability of B complement. Probability of B complement is going to be 1 minus 15 out of 275. And you realize that this is actually 260 out of 275. Again, you could reduce this 52 out of 55, but it's not necessary. Now, so I can come here. I can come here. Someone's requesting to record to their computer. But this recording, the recording of this will be posted on our YouTube channel, so you don't have to worry about that. So you could come here and then substitute. For probability of A, we have 24 out of 275. Probability of B complement, we have 260 out of 275. What's left? Probability of the intersection of A and B complement. Okay. Now, remember we said just by coming, okay, I could use a simple Venn diagram again. A intersection B complement is in fact A only, if you think about it, because we want A, but everything that's in A, but not in B. So that's A only. And A only is in fact A minus A intersection B. So the A complement that we're looking for is in fact A minus A intersection B. That's going to be 24 out of 275 minus 6 out of 275. Yeah, which is, you realize that that's going to be 18, right? 18 out of 275. So you're subtracting 18 from the sum of these two, and that's going to give you 266 out of 275. Now, you could have been clever enough to realize from the beginning that from this expression that we had initially, yeah, that the difference of this and this already gives us the intersection of the two sets just by looking at it. And so you could have reduced this to, you could have reduced the entire expression to probability of B complement plus the probability of A intersection B. That would save you all this, and you just need the probability of this and the probability of this, and then add the two, and you get the answer. But I mean, this is okay. Yeah. Okay, so Claire is asking for a repetition of how I got the probability of A and B. So basically, from the question, given these conditional probabilities, I expressed the probability of B in terms of probability of A intersection B. I also expressed the probability of A in terms of the intersection of the probability of intersection of A and B. And then I use this equation. This equation is very key, and it's always true, to help me find probability of the intersection by substituting for the probability of A and for the probability of B in terms of the intersection. And then I was able to get the probability of the intersection. But remember, probability of A is 4 times the probability of the intersection. So I could get that as 24 out of 275. Probability of B is 2.5 times probability of intersection. So I could get that as 15 out of 275. And then I get the probability of B complement by subtracting that from 1. And then if I add these two, like I said, you should get your answer. Any other questions there? There is none. We can move to the probability of we can move to question 3. Sorry. Yeah. So question 3 again is about conditional probability. Some of you might not have realized this, that it is actually conditional probability, but it is because the commonest way I think this kind of question is solved, the commonest way this kind of question is solved is using a tree diagram. So we're going to look at using a tree diagram, but then you're going to see how it's actually, in fact, conditional probability. Rita is asking how the 0.4 becomes 2.5. 0.4 is when you divide by 0.4, it's the same as multiplying by 5/2. That's that. Musa is asking Musa is asking how I got A union B complement. Based on this equation, that A union B is A plus B minus A intersection B. Similarly, A union B complement is A plus B complement minus A intersection B complement. This equation works for all sets, all pairs of sets. It's always true for all pairs of sets. I just replaced the B with a B complement because that's what the question wants in this particular case. So that's how I got the expression for A union B complement. And even if they ask you for P union Q, you know that it's P plus Q minus P intersection Q. Yeah, the solutions will be shared, yeah. So you don't have to bother copying the questions. The solutions will be shared. Question 3, the probability that a fisherman catches fish on a clear day is 2 out of 5, and on a cloudy day is 7 out of 10. So that statement already biases you to think that the probability of him catching fish depends on the weather. And so when you're starting your tree diagram, you'd actually start with splitting it according to whether the day will be clear, whether the day will be cloudy, because the probabilities we've been given tell us that him catching fish depends on whether it's clear or whether it's cloudy. And we're told that when it's clear, the probability that he catches fish is 2 out of 5. When it's cloudy, the probability that he catches fish is 7 out of 10. That means if it's clear, the chance that he will not catch is 3 out of 5, 1 minus 2 out of 5. And if it's cloudy, the chance that he will not catch is 1 minus 7 out of 10, which is 3 out of 10. Now, the question also tells us, that's the first statement of the question, yeah? It's a good habit to break down questions sentence by sentence. If you digest the whole thing at once, it might not be easy for you to clearly see these things. But if you break down sentence by sentence, especially the new curriculum kids, what does this sentence imply? Then you have some illustration, something for it, or then you move to the next sentence. What does this imply? So the next sentence tells us if the probability that the day is cloudy is 3 out of 5. So probability that the day is cloudy is 3 out of 5. So we can assume that there is no other weather apart from cloudy and clear. And so that if the probability of the day being cloudy is 3 out of 5, then the probability of it being clear will be the complement, 1 minus 3 out of 5, which is 2 out of 5. We've been asked to find the probability that the day is cloudy given the fisherman does not catch any fish. So in other words, they want us to find the probability of it being cloudy given he did not catch any fish. And like I said, this is the probability of cloudy intersection not catch divided by the probability of him not catching. Yeah. Basically, it's asking, so assume he didn't catch any fish. Yeah. What are the chances that on that day it was cloudy? So what you do is you look at all instances when he did not catch, and in how many of those instances was the day cloudy, which is basically what we are doing in this division right here. We're looking at when it was cloudy and he didn't catch out of the times when he did not catch at all. Yeah. So how do we get the probability of it being cloudy and him not catching? Using our tree diagram, uh, this is simple. So we just follow the path of cloudy and him not catching. And so that will give us 3 out of 5 times 3 out of 3 out of 10. And then probability of him not catching, we look at all instances that end up in him not catching. So that also includes when it was clear and he did not catch. So we'll have 2 out of 5 times 3 out of 5, but then plus 3 out of 5 times 3 out of 10. And so this is, you realize in the numerator we have 9 out of 50. The denominator we have 6 out of 25, but I can have that out of 50 as 12 out of 50 plus 9 out of 50. So that this is 9 out of 12 plus 9, which is 9 out of 21, reduces to 3 out of 7. And that's the final answer. Are there any questions to that? Okay, I'll assume that it was very clear. Then if there are any questions, then the next presenter will come and take them on. So let me hand over to the next presenter. The lower part, Rita wants me to repeat the lower part, so let me just repeat one more time, and then I'll hand over to the next person. So the first step really is the most important, that you interpret the question for what it wants. If you don't know what the question wants, then you can't solve the question. The question wants us to find the probability of it being cloudy, given that he didn't catch any fish. Yeah, so we're looking at the times when he didn't catch, on how many of those occasions, or on what fraction of the occasions where he didn't catch any fish was it cloudy. So we have to look at when it was cloudy and he didn't catch, and when he didn't catch at all. So we divide when it was cloudy and he didn't catch, which is the intersection of cloudy and not catching, which is 3 out of 5 times 3 out of 10. The reason we multiply is because if you interpret this tree diagram as it is, it's saying that there are 3 out of 5 chances of it being cloudy. And when it is cloudy, 3 out of 10 of the times it's cloudy, he won't catch fish. So for it to be cloudy and for him not to catch, you have to multiply those two probabilities. 3 out of 5 times 3 out of 10. And all these probabilities come from the question. You just need to follow through on that. And then probability of him not catching fish means we look at when it was cloudy and he doesn't catch, and also when it's clear and he doesn't catch. So the clear and him not catching is 2 out of 5 times 3 out of 5. And then the cloudy and him not catching, as in the numerator, is 3 out of 5 times 3 out of 10. The rest just follows from that. I'd like to hand over to the next presenter.
Good morning, everyone. I would love to know if you can hear me or see my screen.
Yes.
Okay. I would love to carry on from where our previous presenter left us. And we're still doing probability. So we have question 4, which says a bag contains 15 white and 5 red, 5 blue balls. 3 balls are drawn at random, one at a time without replacement. Determine the probability that the first ball is blue and the third one is red. Yeah, so here we are going to use what we call a probability tree, and I think it's the easiest way of representing this. The probability tree is just simply showing how the probability of choosing or an event happening is changing after something has happened, after another event has happened. So really, we're going to see that what is going on here is we're choosing a ball at random 3 times, and those will be 3 balls. So we do not know which ball we are going to pick for all the 3 times. So we are going to draw a probability tree. But then I'm going to just simplify it, and I'm going to start with a blue ball. You know, we could start with something like this. We could have blue, you could have red, and you could have white. And then the chances here could be, for blue could be 5/25. For white is 15/25. And for red, it will be 5/25. Yeah, but then it's going to be a bit messy. So I'm going to just take only the chances for that. I'm going to just take only the chances for starting with blue. So that's what allow me to erase this so that I can do that. So we start with blue happening. If blue is if the first ball to be chosen is blue, then our probability is 5/25. And if the second one is to happen, then we are going to choose either red, white, or blue. So we can either have red. And remember, it's without replacement. So then the sample space keeps reducing. So here the sample space is going to be 24. And since we didn't choose a red ball at first, we shall have to choose from 5. Then we can have a white one. White one is still going to remain 15, but then it's out of 24. Then the blue one, we already chose a blue ball. Assuming we choose a blue ball again, the number of blue balls is going to reduce because it's without replacement. So it will become 4/24. So again, from this one, from the second time, after choosing the red ball, we can again have 3 types of balls we could choose from. Would have red, white, or blue. And the sample space has again reduced to 23. So since you chose the red ball the second time, so that means you'd have 4 red balls left over 23. You haven't chosen a white ball at any of the times, so you have 15/23. And here you have a blue ball, so you have it has reduced to 4 because you already chose a blue ball at first. So yeah, so it's going to reduce to 4/23. So again, also on this one, we can have 3 options. Here we're choosing the red ball for the first time, so it will be 5/23. Choosing the white ball for the second time, so it will be 14/23. We are choosing a blue ball for the second time, so it will be 4/23. Then from this, we can also have 3 options. So we are choosing, let me say this is red, this is white, and this is blue. Choose a blue ball. They already picked out 2, so you have how many? You have 3 left. So the chances are 3/23. Then choosing a white one to be the first time, so you'd have 15/23. Choosing a red one, so the first time, so you'd have 5/23. Now to get the probability of choosing for the first ball being blue and the third one being red, we are going to track. We're going to track where red is as the third ball. So we have here, here, and here. So that means we can either let me just call it the probability could be we could have blue, blue, red, or we could have blue, blue, red, or we could have blue, white, red, or we could have blue, red, and red. So what we are going to do is we are going to find these respective probabilities and then sum them up. So for the first one, blue, blue, red, that means we have 5/25 because you can choose a blue ball and another blue ball and a red ball. Or we can choose a blue ball and a white ball and a red one. And then also, or we could have a blue ball, that's 5/25, then times a red, probability of choosing a red ball, that's 5/24, then times 4/23. Yeah, this is a 4. So yeah, in evaluating that, I think we come up with 1/24. You can help me check that. If there are no questions, I would love to proceed to the next question. How come? Oh, Gabriela Casire, thank you for asking a question, but I wish you can send them as messages to the entire chat so that everyone can benefit. Yeah, but she's asking how come it's not 4/23 for the last white? White, it can't be. I don't know which part are you talking about. I think you could be referring to this one, but for the white, for the probability of choosing white balls, you know, it's, of course, you can even see from the number of white balls, there are 15. So I don't know how it would get to 4. I don't know how it would get to 4 because we're choosing only 3 balls. So I think I chose to start with picking blue because they said the first ball is blue. The question says the first ball is blue. So I didn't want to have a messy tree diagram. So I only took the line of choosing blue. Yeah. And that's how we come up with that solution. So I think we can proceed. Yes, Paul.
I wanted to ask that,
Yeah.
okay, in the question, they said the first ball is blue. I've seen how you've incorporated that, and the third one is white. How did you incorporate that fact that the third.
No, they said the third one is
Oh,
red.
third one is red.
Yeah.
Okay. How have you used that statement that the third one is red?
Okay. This statement logically means if you have to think about the question, they find the probability of the first ball being blue and the third one being red. So in other words, they have restricted that the first ball has to be blue and the last one has to be red. So you can either choose a ball, the second ball as a white one, your second ball could be a red one, and your second ball could be a blue one. And that's how I've encompassed that in this tree diagram. For example, in the first part here, the first ball are very restricted, it has to be blue. So upon choosing your first blue ball, you can upon your second choosing, you can either have red, white, or blue. Then for each of these times, let's say the second time you chose a red ball, the chances of choosing a red ball, white ball, and blue ball are going to change. So here you've chosen a blue ball. Here I've just say you've chosen a red one, and now you're coming to your third choice. If you're going to pick a third ball, it can either be red, white, or blue. But again, they have restricted us; it has to be red. So we strictly have to have that. Then again, if you choose a white ball as your second ball, then you can either have red, white, or blue. But then they want the third ball to be red, so you have to take this. Again, if you choose blue as your second ball, you can either have blue, white, or red. So you take this and that. So I follow the line. So I follow the lines all ending up in red. So I have 5/25. I'm looking at BRR. So I've chosen a blue ball, a red ball, and a red ball. So I have 5/25, 5/24, 4/23. And then and that's what I have here. I think this could be a mistake here. But yes, this multiplication may turn out. So this would have been a 5 and this is a 4. Yeah, but that's for the first one. Then the second one, I could either have blue, white, and red. So I have 5/25, 15/24, and then 5/23. Then the third one, I could either have blue, blue, and red. So I have 5/25, 4/24, and then 5/23. So yeah, that is it. I don't know if I've answered your question.
Okay, yes, I've understood. So when you're taking the probability, you're only supposed to take the line where red has to end up as the third.
Exactly that. Yes, Gabriela, you have your hand raised.
Yeah, my question or issue was when we pick a blue once, then we pick the blue the second time.
Yeah.
The third category at the very bottom, we didn't subtract the number of white balls. We still have 5, which is the original total we began with. That's why I had last whites because I was confused why we had 5/22. That's
I don't
my
know
confusion.
I don't know if I get your question. You mean I don't know. Do you mean this one? The one I've put a star on?
Yes, please.
Pardon?
Yes, please. I mean that one where you put a star.
Okay. Yeah, the number of red balls has not changed. You get, because I've chosen blue and blue. So all the red balls are still inside and all the white balls are still inside. So initially we have 5 red balls. So the chances of picking a red ball has to be the number of the red balls present over the total sample space. So that's why the number of red balls is unchanged and the number of white balls is also unchanged. I don't know if that makes sense.
Yes, it does. Thank you very much.
Got it. Let's go to the next question. But someone can help me verify if the answer is 1/24.
It is.
Can you guys see my screen?
No.
Yes, yes. Let me just magnify it a bit. I don't know if you can see there.
Yes, we can.
Okay. Now, our next question says A and B are two independent events. The probability of A being greater than the probability of B. And then such that the probability of A intersection B is 1/3, and the probability of A union B is 0.9. Okay, thank you, Tracy. So they want us to find probability of A and the probability of B. What information do we have here? We have that we have the probability of A intersection B and probability of A union B. But then we know how all these probabilities are related, especially the ones they're asking for. And the union and the intersection, we know that probability of A union B is equal to the probability of A plus the probability of B minus probability of A intersection B, just as like the first presenter explained. So yeah, we have the probability of A union B as 0.9, and we do not know the probabilities of A and the probabilities of B. But then we know the probability of A intersection B as 1/3. So in this, we can generate an equation relating the two. Probability of A plus the probability of B, and that's equal to 37/30. You can help me check that as well. 37/30. So we have that. But then from our question, we have a condition that probability of A has to be greater than probability of B. So from our equation here, or the expression relating probability of A and B, we are going to generate, we're going to express probability of A in terms of probability of B. And that would mean that the probability of B is equal to 37/30 minus probability of A. So we can make that substitution into this inequality. And that means we have the probability of A is greater than 37/30 minus probability of A. That would give us 2 times the probability of A is greater than 37/30. That leads us to probability of A being equal to, or greater than 37/60. And again, if you make the substitution, you're going to have that the probability of B is less than 37/60. And for a fact, this has met the inequality. So from the conditions we have, or from the question, this is the best way you could go about that. So you're not exactly giving the value, but you're giving the range where probability of A must lie and the probability of B must lie as well. Are there any questions on that? Yes, Paul.
Okay, so I got lost on the part where I said probability of A is greater than 37/30 minus probability of A, and also where 37/60 came from.
Okay, we had that probability of A plus probability of B is giving us 37/30. So we had to express probability of B in terms of probability of A. So that's how we have 37 over 30 minus probability of A. And then our condition is giving us a probability of A must be greater than the probability of B. So using this condition, I substituted for probability of B, and then it gives us the probability of A. We are here. It gives us the probability of A is greater than 37 over 30 minus probability of A. Then I collected like terms to get 2 times probability of A is greater than 37. When you divide through by 2, it leaves us 37 over 60.
Okay, thank you.
You are welcome. Yeah, that was number 5. Let's get to number 6 if there are no any more questions. Number 6 states that a random variable x is uniformly distributed over the interval -3 and 9. Find the variance of x. This is a really simple one because if you have a data set where the data is uniformly distributed and you only have the maximum and minimum, or you have the upper limit and the lower limit, the variance is just the variance of the data set of the random variable is given by that, where B is the upper limit and A is the lower limit. So the variance in this case is going to be 9 minus -3 squared over 12. And this is equal to 12 squared over 12. And our variance is 12. Yeah, that's part A, as simple as that. Then part B wants us to get the probability of x greater than 1 point, the modulus of x being greater than 1.5. So here we have a modulus, and I think we know what that means. So we know that we know that x, modulus of x greater than 1.5 can be plus or minus it can be plus or minus x is greater than 1.5. So this later implies that you can have x is greater than 1.5 or x is less than -1.5. But we want us to get the probability of this chance happening, the modulus of x being greater than 1.5. So we are going to standardize this value of x, the 1.5 and -1.5. So in standardizing, we have to know the mean, and we have to know the standard deviation. And standard deviation is the square root of the variance. And for this case, our mean, we are going to just get the upper limit and the lower limit, the sum of the two, and divide by 2. So we have -3 plus 9 over 2, and that is 3. And the square root of our variance is √12. We can just leave it as that. So in standardizing, we're going to standardize x, and we can call this x1, x2. So in standardizing X1, we are getting Z values, which we shall use to help us attain the probabilities using our logbooks. Okay. I will go back to the previous question. I've been corrected. Yeah. Part B. Part B is about uniform distribution, and we have a data set or a random variable that is uniformly distributed over this interval. So we have to find the variance and we have to find the probability of x, the modulus of x being greater than 1.5. That would mean that we have to find the mean and we have to find the standard deviation. And the standard deviation is the square root of the variance. And the mean, we are going to sum up the limits and divide them by 2. So we have obtained our mean, we have obtained our standard deviations, and that's what we're going to use to standardize our x1 and x2. We'll standardize 1.5 and negative 1.5. So we can standardize the first one. So z1 is going to be equal to x minus the mean over the standard deviation. And our x is 1.5 minus our mean, which is 3, divided by root 12. That would give us our okay. I think the majority of just studied this, but I don't know if I should proceed with it therefore. Okay. Okay, then if most of you haven't studied it, I think I'll leave it at that, because I don't want to proceed when people are not following. Yeah, but for now, I think let me go back to question 5. Question 5, I stand corrected. And we are going to, yeah.
Excuse me, Avi.
Yeah, yes, please.
Kitty is saying, because remember, this is senior 5 and senior 6.
Yeah.
So if this is senior 5 and senior 6, it's highly possible that the senior 6s have covered this. So maybe you could channel that information to them.
Okay.
Yeah, as the senior 5s look at the next number.
Okay, then let me first correct this probability number, then I'll go back to it. Yeah, so the probability number been corrected. that the intersection of the probability of intersection B is equal to the product of the two, probability of A and the probability of B. So that is the condition we are going to use to solve for the probabilities of A and B. So the probability of A union B is just the sum of the probability of A and B. I'm very sorry about that. This was an oversight. So because of the fact that they're independent events, I skipped that. I didn't see that, so that's why I proceeded this way. Yeah, but since A and B are independent events, then the probability of A union B is just their sum. And therefore, the probability of A intersection B is their product. So we can have this. Yeah, and we have these values already. So we can use these and we solve for A and B. So we can substitute for, let's say, probability of B, and we shall have probability of B is equal to 0.9 minus probability of A.
Harvey,
Excuse me, Harvey.
Yes, please.
the intersection is also in the part of the union, yeah? Because it's
Oh,
it's not zero,
okay.
so it's still part of that. It's part of that
Okay.
equation 1.
Okay. So minus P of A intersection B. Yeah, which gives us probability of A plus the probability of B minus a third. And we are going to solve for that. And that a third is equals, this first equation is equals to 0.9. And as we had gotten earlier, probability of A plus the probability of B is equal to 37 over 30. So we have these two equations, this one and this one. And when you make the necessary substitutions, I think we shall be able to get the solution. So from this, we can have that probability of A is times the probability of B, which is same as 37 over 30 minus probability of A is equals to a third. So we have probability of A. Allow me to simplify this, minus 37 over 30 times the probability of A, minus 1 over 3, sorry, plus 1 over 3 is equals to a 0. So we can find the probability of A and B from that. So from our calculator, I think we have we shall have 5 over 6 or we have 2 over 3, 2 over 5, sorry. But then we shall, I think we shall just use both and check the probability of B because they're all less than 1. So the probability of B is equal to 37 over 30 minus the probability of A. So we can take the first one as 5 over 6. So we shall have 37 over 30 minus 5 over 6. and that gives us 2 out of 5. And that means, therefore, if I use probability of A as 2 over 5, probability of B is going to be 5 over 6. But the condition is probability of A is greater than that of B, according to our question. So we shall conclude that probability of A is 5 over 6, and the probability of B is 2 out of 5. Yeah, that was that for that question. Then, for this one, as advised to proceed, so we shall standardize. We get Z1. That would be 1.5 minus 3 over root 12. That gives us negative 0.43. Then Z2 would be negative 1.5 minus 3 over root 12. And that is going to give us negative 1.22 dp, negative 1.30. So we are going to now check. We're going to now check this from our logbooks. But before doing that, we have first make meaning of what we have. So probability of modulus of x being greater than 1.5 can be the same as probability of x less than 1.5, negative 1.5, plus the probability of x greater than 1.5. Upon standardizing, you find that it's going to be the probability of z being less than negative 0.43 plus the probability of z being greater than, it's going to be the probability of z being less than negative 1.3. The probability of z being greater than negative 0.43. Yeah, from our logbooks, you will find that probability of z, or if anyone can help me get that. Now we shall find that these values lie on the left side of a normal distribution curve, which is sort of like that, where this is our mean. So this side represents the negative values, and this side represents the positives. So we have negative z values. That means they are on the left, and we find the probability of z being less than negative 1.3. That means we are going to go to our logbooks, and then we find the probability of z being equal to being equal to 1.3, and then we shall subtract that from 0.5, which is on the left-hand side. So we shall have 0.5 minus the probability of z being equal to this is a z being equal to 1.3. So that's what we have here. Then on this right-hand side, we shall have, on this other z value of negative 0.43, we shall have we shall have 0.5 minus the probability. Sorry, it has to be 1 since it's greater. Sorry about that. Greater than 0.3, that 0.43, that means it's about here. Negative 0.43 is about them. So we shall have 1 minus, because now we're looking at everything greater than 0.43, so we're looking at everything towards the right. Shall have 1 minus probability of 3. Yeah, and then I think this will give us our answers. So from our logbooks, we have 0.5 minus a probability of z being equal to 1.3, shall have 0.4032, then plus 1 minus probability of z being equal to 0.43. It's going to be 0.1664. And when we evaluate that, we have 0.9304 as our final answer for that part. Oh yes, you have question written, Mark.
Good morning, sir. I'm kindly requesting you go back to the part of independent events.
Okay. Yes. Yes, please. I don't know if you can see my screen.
Yes, I can see the work, but I thought when they're independent events, we don't include the intersection.
Independent events.
Yes.
I could answer that. If two events are independent, it simply means that they don't.
They have no intersection.
No,
yes.
no, no. They have they can have an intersection. It simply means they don't influence each other. That's what the word independent means. Like it
Well-
raining and um it raining and the seminar happening. The seminar will happen. Those probabilities don't affect each other. In other words, they're independent. And so their intersection is actually the product of their probabilities. That's the thing about independent events. Events that have no intersection are called mutually exclusive events. And if two events are mutually exclusive, it means they can't happen at the same time. For example, the sun rising, the sun
The
setting.
sun setting.
It can't happen at the same time. So those two events are mutually exclusive. Those two events have an intersection of 0. So when the question says that two independent events A and B, it's simply telling you that their intersection is in fact the product of the two probabilities, but it doesn't mean that it actually tells you their intersection is a third. Yeah, it's not 0. So that means they have an intersection, which is just the product of the two probabilities. I hope that makes sense.
Can you please scroll a bit and I see the product license? So you made it a quadratic equation?
Yes, please.
You made it a quadratic equation?
Yes.
Okay. Then wait, why did you add 1 out of 3 and then get 0? Because I thought it would be 1 out of 3 minus 1 out of 3. So this minus 1 out of 3 equals 0.
I collected like terms from here. From here, you'd expect to have negative probability of A squared plus 37 over 30 PA is equals
Yes.
to 1.3. So I took everything to the right-hand side and I ended up with that equation.
Okay. Okay, yeah.
Yeah, thank
So
you.
do you mind explaining the whole number? Because it seems like also some people have not understood.
Okay. Yeah. A and B are two independent events, and that means for independent events, that means they can't happen at the same time. So, the intersection would have been 0, as they explained earlier, but then we have been given a value. And if they have a value, then the intersection is just simply the product of those two, probability of A and the probability of B. So that's why I get, that's why we have that. That's why we have the probability of intersection B is the probability of A, then probability of B, which is equals to a third. And from our first expression, probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. You make the substitutions and you come up with an equation with this probability of A plus probability of B is equals to 37 over 30. So that gives us two equations that we can deal with, and we solve them simultaneously by substitution method. Then we get the values for the probability of A and the probability of B. But then from our equation, it's a quadratic, so we expect two values of probability of A. And that's why we have 5 over 6 and 2 over 5. But then you have to you check with both and see what values of probability of B you get. And when we checked, we found out that if I use 5 over 6, I get 2 over 5. And if I use 2 over 5, I get 5 over 6. So I have to take the values such that the probability of A is greater than that of B. So that's why I took these two. Yeah.
Right. We shall move to the next question,
Excuse me.
which was number 7. So someone has
Excuse
a
me.
question?
Yes, Kitty, I'm so sorry. I had a question for Harvey.
Yes, please.
It's to do with number 6. Maybe if you could kindly display number 6.
Oh, yes, please. Let me get to it. Yeah.
Kindly scroll further down. Yes, so okay, I kind of have a very big concern with standardizing. Okay, I was taught that standardizing works for a normal distribution. But
Yes.
seeing that Yes, but seeing that this is a uniform distribution, I had something completely different, like something else in mind.
Oh, yeah,
To summarize what I had, I was thinking that this in a uniform distribution, you only have to do subtraction of limits. That's what I had in mind. Then the standardizing is in the normal distribution. I don't know, maybe if you could maybe elaborate more on that.
Yeah, you are absolutely right. The question was saying uniformly, and I read it as normal. So if we could maybe just take the question as what?
As normal, eh? Okay.
Yeah.
Okay. Thank you.
Yeah, sorry about that. I read it as normally. So and that's why I evaluated it that way.
Oh, okay. It's okay. Thank you so much.
Kali, you're welcome.
Excuse me, please. Excuse me, teacher.
Yes, please.
On the same number 6, could you please display it back part B, where we're dealing with getting those values from the logbook? Yeah, you realize that when you get your values of Z, we use the calculator.
Okay.
We're told that we get 3 decimal places, like it would be 0.433. Then that other part would be negative 1.30. So that when you come here so our values would change when you come to the probability getting Z.
Okay.
From the standardizing it, because you would have a 0.433, which should require us to use that other column in the logbook for adding. So you wouldn't have this answer as 0.1664. I think it would change to 0.1675, because okay, when you take decimal places,
yes,
errors arrive if you don't use the required decimal places. I don't know whether you get.
Yes, I do, and I understand you really well. Maybe that was just another mistake. Yeah, and when you do that, what value do you get?
My final answer is 0.9293.
Okay.
Thank you.
Thank you too.
Yeah, good morning, guys. We shall move to the next question, which is number 7. And it reads, Melissa sits for 4 examinations in her class. If the probability of passing an examination in her class is 0.25, find the probability that she passes. I hope you guys are seeing my screen. Yeah, so the question is still from probability. And once you're given such a question, you need to know the kind of distribution you're working with. Yeah, now for this question, it's a binomial distribution. Reason, we have an event occurring, and there are 2 chances of having that, there are 2 outcomes we can have. We can either have a success or a failure. And those events are independent events. Then we are seeing that the event is being carried out for a repeated number of times, because she's sitting for the exam. She's sitting 4 exams. So it's like the event is repeated. Yeah, and the number of times it's occurring is less than 20. So we shall clearly use the binomial distribution. Yeah, so as we said, you can either have a success or a failure. And in this case, our success is passing the exam. So our success, which is noted by P, is equal to 0.25, which means that our Q will be equal to 1 minus P, 1 minus 0.25, which is equal to 0.75. The event is carried out for 4 times because she's sitting for 4 examinations. So it means that our n is equal to 4. It's a binomial distribution. And that has to find a probability that she passes part A only 2 examinations. So probability of passing 2 examinations.
Excuse me, what Q?
Hello. Does someone have a question?
Yes, I'm wondering what's Q and N.
P is the probability of having a success in that scenario, which is 0.25. That's if she passes the examination. Okay, to understand your success, you need to know what the question wants. In this case, they want the probability of passing. And the probability we're given in the question, the 0.25, is the probability of passing the exam. So our 0.25 becomes the success, and it is denoted by P. These are standard things, conventions. So P is P is the success, which in this case is passing. It's a 0.25. Then Q is the probability of having a failure, the probability of her failing an exam, which is got by subtracting 0.25 from the total probability, that is 1, to get 0.75. Then N is the number of times the event has been carried out. In this case, she sat 4 examinations. So yeah, 4 is our N. Yeah, so probability of passing 2 examinations. First of all, from the formula, know that probability of X being equal to R is got by taking N combination R times P power R times Q power 1 minus R. So in this case, our R is 2, because you're looking at just 2 examinations. So she'll have probability of X being equal to 2 as our N is 4, our R is 2, 4 combination 2 times P, which is 0.25 power R, which is 2, then times Q, which is 0.75 power 1 minus R, which is 4 minus 2. So when you work out that, you end up with your probability. If someone has a calculator, get us that value. If someone has got it, you can tell us the answer.
I have 0.2109375. I don't know if others agree.
0.2109
375. I've just given you all the digits.
375. Yeah. Since we are calculating, you can first write all the decimal places. We're not using a logbook, so you can first write all the decimal places and round off to the required full number of decimal places, which is 0.21094. But you could also use a logbook to read it off directly. Okay, I don't have a logbook here, so, but I guess those who have logbooks will get the same answer. Yeah, so that's our answer for part A. Then part B, we wanted us to get the probability of passing less than half of the examinations. So we know that half of 4 is equal to 2. So probability of passing half of the examinations will be probability of X being less than 2. And that can be got by getting the probability of not passing any, because we also have that option. You can pass you can pass one examination, or you may not pass at all. So we also have to consider that 0. Shall get probability of x being equal to 0 plus probability of x being equal to 1. Those who have logbooks, you can read off these values. I don't have a logbook, sorry, so I'll just calculate. But both options carry the same marks. So when x is equal to 0, it will be got from 4 combination 0 times 0.25 power 0 plus 0.75 power 4 minus 0, which is 4. Then plus, when x is equal to 1, we shall have 4 combination 1 times 0.25 power 1 times 0.75 power 4 minus 1, which is 3. What are we getting for probability of x is equal to 0? I hope I'm not so fast. Yeah, the answers are supposed to be to 4 decimal places. So 1, 2, 3. Yeah, you round it off to 4 decimal places, sorry. 0.2109. For part A. What are you getting for probability of x is equal to 0?
Kitty, I have 0.31.
0.31
64
64.
0625.
Okay, 0. Oh, okay, we can just take from 4 decimal places plus
0.42.
0.42.
18.
18.
75.
So you can take 1 8 what?
1875.
So it's 19 to 4 decimal places. Thank you. Then when we add up that two, what do we get? No, from 5 you can keep around if you never know the next question you get. This is 0.7383. Or alternatively, since we got probability of x is equal to 2. Does someone have a question? Francis, you are unmuted. I think you can mute. And someone is asking how we use combination, how we work out combination in a calculator. Okay, I don't have a calculator here, but if I'm to use my digital calculator, for example, if I'm getting 4 combination 0, I'll press 4. Then for my calculator, it is shift, then division. So shift, division, which is that, they'll bring a C. Then I'll type a 0. Then I'll write times 0.25 power 0. Then times 0.75 power 4, and then give me the answer. That's how we work it out. Okay, so for that question, I was giving us the alternative. So realize that in the previous part, we got probability of x being equal to 2. So we can use that probability to help us get a probability of x being less than 2. Because you know that maybe if I draw a number line here, I can have 4 different probabilities. There's probability of not passing any exam at all, then probability of passing 1 exam, probability of passing 2 exams, probability of passing 3 exams, or probability of passing all the 4 exams. So if I want to use 2 to help me get probability of passing less than 2 exams, because I have probability of x being equal to 2. So I can say that probability of x being less than 2 is equal to 1, which is the total probability, minus the probability of x being greater than or equal to 2. Something like that. I don't know whether we are together. Are you together? Guys, are you together? I hope so. So this probability of x being greater than or equal to 2 can be read off from the logbook. But unfortunately, I don't have a logbook here. But you can easily read off the cumulative probabilities, x being greater than or equal to r. If you flip over to the next page of the logbook, having the cumulative normal distributions, this can be read off directly from the logbook. Does someone know how to read them off so that they can tell us that probability? So we would have 1 minus. Max, do you have your logbook there?
Do I have
your logbook?
It's not near me, but
okay, it's okay. But the cumulative normal probabilities can be read off from the logbook. So in case you want to use, in case you don't have to go through the tedious process of calculating, you can just read it off from the logbook, and you take 1 minus that probability. Unfortunately, I don't have a logbook here, so we can't get it. Yeah, but that's how we get it if you're not using a logbook for the first method. Yeah, we shall move to the next question. I hope that, okay, someone is telling me 1 minus. Okay, maybe we shall see how to read it off from a logbook. At the end, I'll try to see if I can get it. We shall go to the next question. But I hope you understood the first method, because that can also give you the marks. So the next question reads, 2 events, A and B, are such that probability of A complement given B complement is equal to 2 out of 7, and probability of B is equal to 2 out of 3. And that has to find the probability of A union B. So we are going to use these values that we have been given to help us get the probability of A union B. So when I look at what I have, okay, the formula we know is that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Yeah, so when I look at what I have, I don't have probability of A intersection B. I have probability of B, but I don't have probability of A. And the information I've been given cannot help me get probability of A. So that method will not work in helping us get probability of A union B. But when I look at what I have here, the probability of A complement given B complement, I know that probability of A complement given B complement is the same as probability of A complement intersection B complement out of probability of B complement. Yeah, so I think this, when you look at what I have on my right-hand side, the probability of A complement intersection B complement can help me get the probability of A union B. Because I had probability of probability of A complement intersection B complement is the same as probability of A union B, but complement. We saw that as we were deriving from while using the sets method. Probability of A complement intersection B complement, the same as probability of A union B complement. I hope that's clear. So we can use that to help us get probability of A union B. Okay. So I've been told that probability of A complement given B complement is 2 out of 7. So I can substitute and I'll have 2 out of 7 being equal to, I know that probability of A complement intersection B complement, same as probability of A union B, but complement. Then everything out of probability of B complement. Yeah, so I know that probability of, Jonathan told us that probability of B plus probability of B complement gives us 1. So we can get probability of B complement by subtracting 2 out of 3 from 1. Yeah, so it means that on the left-hand side, we shall have probability of A union B but complement out of 1 minus the probability of B, which is 2/3. And we shall end up with 2 out of 7 being equal to probability of A union B but complement out of 1/3. So when I cross multiply, I'll end up with probability of A union B but complement being equal to 2 out of 7 times 1 out of 3. What does that give us? I think it's 2 out of 21. Yeah, so still from that principle, we know that, we know that probability of B plus probability of B complement is equal to 1. We can extend that to probability of A union B at complement. A probability plus its complement always gives us a 1. So it still means that probability of A union B plus probability of A union B but complement is equal to 1. Now take note, my complement is outside the brackets. Yeah. So probability of A union B but complement would be equal to, probability of A union B, since I'm looking for that, would be equal to 1 minus probability of A union B but complement. Therefore, would have 1 minus 2 out of 21, which gives us 19 out of 21 as the probability of A union B. Is that clear? Does anyone have a question for part A? Okay, silence means no. So we shall go to part B. Let me first get a page. The part B wanted us to find probability of A intersection B complement. Probability of A intersection B complement, or probability of A only. So probability of A only can be got from getting set A minus subtracting the intersection of those two sets, if I use the set concept. Yeah, so if I have probability of A and I have probability of A intersection B, I can get probability of A only using that formula. But when I look at my question, I don't have probability of A. So it may be hard for me to get that probability while using that method. Yeah, so I can go back to the contingency table where I have probability of A and probability of A complement, then probability of B, and probability of B complement. So I would have probability of A intersection B, then probability of A intersection B complement, then probability of A complement intersection B, and probability of A complement intersection B complement. So the probability of probability of A intersection B complement that I'm looking for is right over here. Yeah, and that for that row of our contingency table, we have probability of B complement being equal to probability of A intersection B complement plus probability of A complement intersection B complement. So I'm looking for probability of A intersection B complement. I'll make it the formula, the subject of our formula. So probability of A intersection B complement would be equal to probability of B complement minus probability of A intersection A complement intersection B complement. So probability of B complement is 1 minus 2/3, 1 minus probability of B, then minus probability of A complement intersection B complement. We got it in the previous part. It's 2 out of 21. Remember, probability of A union B complement is the same as probability of A complement intersection B complement. So that's what I'm using. So we shall have a third. Shall have a third minus 2 out of 21. And what do we get? Times 7 times 7. We get 5 out of 21 as probability of A intersection B complement. Is that clear?
Yes.
Does anyone have a question regarding that part? Silence means
Excuse
no.
me.
Yeah. Yes.
I wanted to know like how the table came about, because that part kind of confused me.
Okay. Oh yeah. So I have two events, A and B, and I want to see how that table can help us get those probabilities. So I can put them in a table which they call the contingency table. You don't have to show it as you're working, by the way. It doesn't carry any mark, but knowing it just simplifies your life. So I can put probability of A here and probability of A complement here. So when I add probability of A to probability of A complement, I get a 1. I can put that 1 here. And I also have probability of B and probability of B complement. And when I add B, probability of B to probability of B complement, I end up with a 1. Yeah, so that is that and that is that. A plus A complement gives me 1. Then B plus B complement still gives me 1. Yeah. Then I look at this area here. It's taking the intersection of A and B. So I put it in that section, probability of A intersection B. Now also look at this area here. It is the intersection of A and B complement. So I will put probability of A intersection B complement in that field. The same is done for the remaining fields. The area here, it's an intersection of A complement and B. So probability of A complement intersection B. Then the area here is the intersection of A complement and B complement. So I'll have probability of A complement intersection B complement. So it means that the probability of B complement is got by adding probability of A intersection B this probability here. This probability of B complement will be got by adding that field to that field. That's what I use. Probability of B complement is equal to probability of A intersection B complement plus probability of A complement intersection B complement. If I wanted probability of B, I would add this to that. If I wanted probability of A, I would add this to that. I hope it's clear to the person who asked.
Yes, it's clear now.
All right. So we shall move to the next question, which is from still from probability, but it was tackling continuous random variables. So it was that a continuous random variable has a PDF given us that. Yeah, so in continuous random variables, you can be given a probability density function or a cumulative density function. So you have to be very careful before you start solving your equation. Is what I've been given starting with small f or capital F. That capital F means cumulative density function. Small f, probability density function. Yeah, so that's very key. So that's our distribution. F of x is equal to that. Then they're telling us to sketch a small f of x, which is the PDF, and hence find the value of k. They're telling us to sketch first and find a value of k later, not getting the value of k first and sketching. That also is important. So you have to first sketch and after use our sketch to find the value of k. Now the value of k can be found using two methods. It can be got from the graph or by integrating. Now this question has restricted us to one method, getting that value of k from the graph, because they're telling us to first sketch, and after sketching, we use that sketch to get the value of k. Yeah, so if I'm to sketch our PDF, I first of all have to find the values of f of x, the corresponding values of f of x to these limits, -1, 1, 1, and 3. So I'll start by calculating for those values. So I will draw a simple table where I have x and then f of x. So when x is equal to -1, I'll have to get the value of f of x by substituting for x here. When I put -1 here, I'll have -1 plus 3, which is 2. So f of x will be equal to 2k. Then when x is equal to 1, when I put a 1 here, I'll have 1 plus 3, which gives me 4. So I'll have f of x as 4k. Then we still had 1 in the next equation. where f of x is equal to k. So in the next range where f of x is equal to k into brackets 5 minus x. So when x is equal to 1, I'll still have 4k. It will be 5 minus 1 to give me 4. So 4k. Then when x is equal to 3, I'll have 5 minus 3, which is 2. Therefore, I'll end up with 2k. Yeah, so I can use those values to sketch my PDF. Remember, these sketches are not drawn on graph paper. Yes?
I just have a concern. Yeah, we were told, okay, I know that if you've done it the way you've done it, sometimes it's misleading and it's possible to lose a mark. I thought maybe you would specify the range on a certain function instead of going the whole way, because okay, sometimes it looks like it's one function next and yet there are two. Yeah, so but anyway, it was just something that I was thinking.
Okay, thank you for that thought. So what were you suggesting we should do?
I
Just
think
write
it
them
would
out
be
that for -1 less than x less than or equal to 1.
perfect. Then you say then you
of
put
-1.
Then you get its value.
Yeah, that can also work. F of -1, then you substitute and so on. Then you go to the next
Yeah.
range.
Then you go to the next
and you work
range.
it out. Okay. Thank you. Thank you. Okay. Yeah, so continuing with this, yeah, so we are sketching. The sketch is not drawn on graph paper. It's drawn just on the answer sheets where you're working from. So you don't have to ask for graph paper. You'd actually lose marks. So we have 0 on the x-axis. We have 0, then -1, then 1, 2, then 3. Then on the vertical axis, we have 2k and 4k. Yeah, so when x is equal to -1, f of x is equal to f of x is equal to 2k. Then when x is equal to 1, f of x is equal to 4k, which is somewhere there. So when I join that 2 with a solid line, I'll have something like that. I have to name my function. So this is f of x being equal to k plus k into x plus 3. I'm handling the first range for that first line. That first straight line is handling the first range. So I can put some dotted lines here because they're going to help me in calculating the areas. That's our first function. Then the next function, where for the range 1 less x less than or equal to -3, when x is equal to 1, we still remain with 4k. So I don't have to plot, I'll just consider that very point. Then when x is equal to 3, we have 2k. So 3 is here, then 2k is here. So my point is over there. Then I join those 2 points with a straight line. And then I name that part of the function as f of x being equal to k into 5 minus x. Okay, that's our sketch. Then I also have to label my axes. This is the x-axis, and this is the f of x-axis. I hope that's clear, members. Yeah, it's clear. Hope so. Yeah, we finished sketching our function, and then they're telling us to get the value of k. So the value of k will be got by considering the area under that graph. You know, for a continuous random variable, the total area covered by that graph is equal to 1. The total area under that graph is representing that total probability, which is 1. So if I get the total area under that graph, and I add it up, if I sum up the area of the shapes under that graph, I'll get a total of 1. So I can get those shapes under that graph, calculate their areas, add them up, and equate them to 1. Then that way, I'll be able to get the value of k. Yeah, we have two trapezia. We have one on the right and one on the left. But I can also use I can divide the shape into that form so that I have a rectangle and a triangle, which I think is easier to use and calculate the area of those two shapes and equate them to 1. So probability of the first shape, which is a rectangle, will be got by length times width. So a length is the difference between 3 and -1 is 4. So our length is 4. Then the width is 2k. That distance there, 4 times 2k. Then the area of the triangle, the height is the difference between 4k and 2k, which is k. So a half times times height, which is the k. Then times the base, which is still 4. And then I will equate that to 1. So 4 times 2k gives me 8k. And that will give me 2k.
Excuse me, Kitty.
Sorry, 4. Yes?
4k minus 2k for the triangle.
4k minus 2k for the height.
Yeah,
thank
for the
you.
height.
Thank you very much. 4k minus 2k, which is 2k. Yeah, so half times 2k times 4 will give me 4k. And I'll equate that to 1. So 8k plus 4k is equal to 12k, being equal to 1, and therefore k is equal to 1 out of 12. Yeah, that was the question. Does anyone have a question regarding that? So in this case, if you found the value of k by integrating, you wouldn't get the max because they told you to first sketch and use your sketch to get the value of k. So you are restricted to only that method. Dave, where do you want me to? Dave, what's the problem? We got the value of k by calculating the area under that graph. I use the area of this rectangle here. Its length is 4. If I get the distance between -1 and 3 on the x-axis, it's 4, and its width is 2k. The difference between 0 and 2k is 2k. Then I also use the triangle here. It had a base of 4 units and a height of 2k units. When I sum up those two areas, they'll give me the total probability, which is 1. So that way I can get the value of K. Okay. The recording will be uploaded to our YouTube channel, so you will follow through. Yeah, then the last question under probability, it reads, a biased tetrahedral die whose faces are labeled 1, 2, 3, 4 is such that the probability of getting an even face is twice as likely to occur as getting an odd one. Then let us to find the probability of getting 4 not less than twice in 10th rows. Yeah, so this question has very many aspects that we shall have to tackle. So we can go sentence by sentence. We have been given a die whose faces are labeled 1, 2, 3, and 4. And they're telling us that the probability of getting an even face is twice as likely to occur, is twice as likely as getting an odd one. So I can start from there. So in our solution, we can start by finding those probabilities, that of getting an even face and that of getting an odd one. So I can let the probability of getting an odd one I can let it to be letter X. Such that odd face is X, then even face would be 2X. If I sum up those two probabilities, I get a total probability of 1, because you only have two options, odd faces and even faces. So probability of getting odd face plus even face gives me 1. So to find a value of X, I'll use that property. X plus 2X is equal to 1. 3X is equal to 1, and therefore X is equal to a third. So it means that probability of getting an even face is 2/3. Yes. Then probability of getting an odd face is a third. So telling me that find the probability of getting 4 not less than twice in 10th rows. So if I'm to interpret this question and find out the type of distribution I'm working with, I'm actually working with a binomial distribution, because this event is being carried out repeatedly. We have very many throws. I throw a first time, second time, and so on up to 10 times. Then I'm interested in I'm looking at 4, particularly 4. So when I throw, I can get the 4 that I want. If the 4 shows up, that's the success. But if I throw and get any other number that's not a 4, that's the failure. Yes. So we have the probability of having an even number and then the probability of having an odd number. But we are interested in getting the probability of getting a 4. So we are not yet there. We have to calculate the probability of a 4 showing up. We can use a tree diagram to help us get that probability. So I toss my die, and I have two options. I can get an even number or an odd number. But when the number is even, the chances will be 4. The chances of having that even number are, okay, the probability is 2 out of 3. So the even numbers are 2. I have a 2, and I also have a 4 from my set of choices. From my set of options, I can have a 1, 2, 3, or 4. But for me to get an even number, it can either be a 2 or a 4. So it means that for me to get a 2 and then a 4, for me to get a 2, the chances are 1 out of 2. And for me to get a 4, the chances are 1 out of 2 still. So it means that the probability of me having a 4 would be equal to 2/3 times 1 out of 2. Therefore, probability of having a 4 is equal to 1/3. So that's my probability of getting a 4. And in this case, it will be my success. Or alternatively, we could have gotten that probability of having a 4 by drawing a table. And yeah, so we have 4 numbers, 1, 2, 3, 4. And they have told me that my probability of having an odd number is, okay, my probability of having an even number is twice as likely as that of having an odd number. So for odd numbers, assuming the probability of getting an odd number is x for 1 and x for 3, it means that the probability of having even numbers would be 2x. So 2x there and 2x there. So if I sum up those probabilities, I would have x plus 2x plus x plus 2x, and the total probability would be equal to 1. Yeah. So 2x plus 2x plus x plus x would give me 6x. So 6x would be equal to 1, and therefore x is equal to 1 out of 6. But probability of having a 4 is equal to 2x, which means that probability of getting a 4 would be 2 times x, which is 1 out of 6, and therefore that probability is equal to 1/3. So you see that we are getting the same answer, probability of getting a 4 as 1/3. So yeah, you can choose what works best for you. This is an alternative for just that part of getting the 4. Well, we are still working out our question. And that's to get the probability of getting 4 not less than twice in 10th rows. So as I've told you, this is a binomial distribution that is being carried out for 10 times. We have 10th rows, so n is equal to 10. Then the success, which is p, is 1/3. In this case, that 1/3 is representing the probability of getting a 4. Yes. Then the failure will be the probability of not getting a 4, which is 1 minus p. So 1 minus 1/3 will give me 2/3. Hope we are still together. So what these people are looking for is the probability of getting 4 not less than twice. So you're looking at 2 times and above. So what we actually want is probability of x being greater than or equal to 2. That's what we are looking for. Now, in this case, we could have read off that probability directly from the cumulative, the table having cumulative results for normal distribution. But our value of p is 1 out of 3, which is 0.3333, and so on. When you go to your logbook, you will not find that value, which means we cannot use our logbook in this case. We cannot use the tables to get that probability. So the only option we have is to use our calculator. And when you're using your calculator, it means that you'd have to get individual probabilities. Which means that if I had to get probability of x being greater than or equal to 2, we would have to get probability of x being equal to 2 plus x being equal to 3 plus so on, plus probability of x is equal to 10. But realize that that would be very would be very tedious. So we can look at this the other way around. I can draw my number line. The possible choices that can come up if I toss my, if I do what? If I toss that thing, I can have 0, I can have an offboard, then I can have a 1, I can have a 2, I can have a 3, 4, 5, very many values in between, up to 10. So I'm looking at my 2, which is there, it's a point I'm basing on. Yeah, so I want to use only these values here. I want to use only 0, 1, and 2. Because realize that if I'm to use 2, 3, and so on, would spend a lot of time working it out, and yeah, may even not complete the paper because of that. So I can look at 2. I can look at everything that's less than 2. I only have 0 and 1. So it means that if I'm to get probability of x being greater than or equal to 2, since the total probability is 1, I can get that probability from a probability of x being less than or equal to 2 as the total probability minus the values that I'm not, the probabilities that I'm not interested in for that particular question. And those probabilities are x is equal to 0 and x is equal to 1. So it would be 1 minus the probability of x is equal to 0 plus probability of x is, or 1 minus probability of x being less than 2. So it would be 1 minus probability of, let me use a big bracket here, 1 minus probability of x is equal to 0 plus probability of x is equal to 1. I hope we are still together. Yeah, so this would be shorter. This formula here would be shorter than this one. Yeah, so I'll go back to the formula for binomial distribution and I'll use that. So probability of x being less than or equal to 2 would be equal to 1 minus, when x is equal to 0, I would have 10 combination 0 times p, which is a third, power 0 times q, which is 2/3, power 10 minus 0, which is 10, then plus, when x is equal to 1, I'd have 10 combination 1 times a third, power 1 times 2/3, power 10 minus 1, which is 9. So I would end up with 1 minus, which values are you people getting? Is someone calculating those probabilities? Okay. I have 10 combination 0.
Kitty.
Yes?
For the first one, I'm getting 0.017. Sorry, actually for the for the first one, 0.0173.
Then for the second one?
For the second one, I'm getting 0.08.
Oh, sorry, 0.8.
0.08671. Actually, 0.0867. without the 1. Kitty, I had a small question.
Yes.
Could you kindly scroll up a bit? Yeah, that part of 1 minus probability of x less than 2, Can someone say 1 minus probability of x less than or equal to 1?
But yeah, it's very okay. Because I'm just looking
Okay.
at 0 and 1.
Okay.
Yeah. So what is our final answer? Minus 0.0173 minus 0.0867.
0.896.
0.896. To 4 decimal places. Okay.
Yeah.
Yeah, thank you very much. Yeah, so does anyone have a question? Yeah, thank you very much. I don't see any questions, so I guess that's it for the probability section. I'll hand over to Jonathan for statistics. Let me stop sharing.
Okay, thank you, Brian. Yeah, so we're going to move on to the statistics questions. If you're around, please stay on the call. They're just 6 statistics questions. And yeah, there's a feedback form that's going to be sent in the chat. So please just fill that feedback form. So let me proceed with presenting. Yeah, so before we go any further, I'm just going to offer clarity on number 6, which was done earlier, because the solution provided was for a normal distribution, but it's actually a uniform distribution. I hope you can all hear me. If you can't hear me or see my screen, please let me know in the chat. Yeah, so the variance of a uniform distribution, just a brief summary actually on the uniform distribution. Uniform meaning the same. So the probability is the same at every point within the interval over which the distribution is defined. And I like to represent it as a graph. If we represent this as a graph, we'll see that this being the x-axis, if this point is -3 and this is 9, this is the distribution, like this is the probability, yeah? This is the f of x. And of course the y-axis is somewhere here, because when x is 0, that's where the y-axis is somewhere there, but it's not important in this case. Everywhere else along the x-axis, the probability is 0 because it's only defined at this interval, -3, -3, 9. Now the variance of a uniform distribution is given by the formula b minus a squared over 12. This is a known formula. It can be derived, but I'm not going to get into that. B minus a squared b minus a squared divided by 12. Now, let me just represent this. Sorry. The probability okay. This is the probability for a uniform distribution. The probability is 1 out of b minus a. For all points within this interval from a up to b. So in this particular case, our a is -3 and our b is 9. So f of x is going to be 1 out of 12 because 9 minus -3 is 12. And this is from -3 up to 9. The reason it's 1 out of b minus a is because since it's uniform, and the total area under this curve here, the total area under the curve has to be equal to 1 because total probability is equal to 1. For those in S6, you know that for a continuous random variable, the integral, the area under the curve is given by the integral. The integral from a to b, from the lower limit to the upper limit of the interval over which the distribution is defined, of the function should be equal to 1 because the total probability should be equal to 1. And so 1 out of 12, that's why we have 1 out of b minus a, because f of x times this interval here should be equal to 1. So 1 out of 12 times 12, because 9 minus -3 is actually 12. When you multiply 1 out of 12 by 12, you should get 1. Now let's come back to this. The variance would be 9 minus -3 squared out of 12, which when you work it out, you get 12 because it's 12 squared divided by 12, which should give you 12. Now the probability that the absolute value of x is greater than 1.5, can be split into two. We can either have x less than -1.5 or x greater than +1.5. This absolute value of x means basically the positive x as a positive number, or how far x is from 0. So the absolute value of -1.6 is in fact +1.6. Absolute value of 1.6 is just 1.6. So for negative numbers, the absolute value turns them to become positive numbers. Positive numbers remain positive. That's why a number that's less than 1.5, its absolute value is actually greater than the absolute value of a number less than -1.5. Will have an absolute value greater than 1.5. You can check -2 is less than -1.5, but 2 is greater than 1.5. So for the negatives, we'll pick a number less than -1.5, and for the positives, a number greater than +1.5. Now, if I'm to use this graph that I've drawn, -1.5 is somewhere there, +1.5 will be somewhere there. So what I'm in fact looking for is the probability of this plus the probability of that. So you could actually write this as the probability of -3 less than x less than -1.5 plus the probability of 1.5 less than x less than 9. Now for continuous random variables, you know that this should be the integral of -3 to -1.5 of the function, which is 1 out of 12 with respect to x. If you're in S5, don't worry about this. This is 1.5, from 1.5 to 9, 1 out of 12 with respect to x. And when you calculate this, you should get 3 out of 4. Now, alternatively, you could decide to get the probability of the complement. And this is the complement. And then subtract it from 1. And this looks like 1 minus the integral from negative 1.5 to 1.5 of 1 out of 12 dx. To still give you the same answer. So that's how number 6 was supposed to be done. Sorry for the confusion that came about. So now I'm going to go to the first statistics question. And here it is. A set of digits consists of m zeros and n ones. We're asked to find the mean of this set of data. Now from O level, really, or from primary actually, you know that in simple terms, the mean is equal to the sum of items divided by the number of items. But I'm going to write it in a more mathematical way. Okay, now you're mature. You can write like this. If you have n items, yeah? If you have n items, the mean, yeah, the mean is in fact the sum of all the items. So xi, where xi is an individual item, yeah? From 1 up to n. So this, what this means is really just x1 plus x2 plus all the way up to xn out of n. So you have n items and you divide by the number of items, which is n. Now in this particular case, how many items do we have? We have m zeros, yeah? M zeros, so you have 0 plus 0 plus 0, m of them, yeah? And then n ones, so 1 plus 1 plus 1. And the number of items is going to be m plus n. Now when you add this, 0 plus 0 plus 0 is always 0. Then 1 plus 1 plus 1, since they're n, have n of them. So this will be n out of m plus n. So that's the mean. And now for part B, we want the standard deviation. Now the standard deviation is just the square root of the variance. So what I'm going to do really is first find the variance. Now variance, from what we know, variance is the expected value of x squared minus the mean squared. So in other words, in this particular case now we have xi squared up to n. We're dividing this by n, and then we're subtracting the mean squared. That's what the variance is. So what we actually have is 0 squared plus 0 squared. Remember, there are m zeros and then n ones. Dividing this by m plus n. Since we found the mean in the first part, we already know that it's going to be n squared out of m plus n squared. They want us to show that the variance, sorry, the standard deviation is square root of mn over m plus n. Now you realize that 1 squared is the same as 1. So in this case, we'll still get n out of m plus n, and we're subtracting n squared out of m plus n squared. Now when you work this out, if you use the LCM of the denominators, which should be m plus n squared, you end up with n times m plus n minus n squared in the numerator. And you realize when you open bracket, you'll have nm or mn out of m plus n squared, because the n squared takes itself away. So that's your variance. And now standard deviation is the square root of variance. So that means the standard deviation will be the square root of mn over m plus n squared, which is just the square root of mn divided by m plus n. And you'll have shown what you're supposed to show. Mark.
So Jonathan, I just got confused on the part of m plus n squared in the denominator, how it became m plus n for the variance.
Which step exactly?
Okay. Is variance. So that part where you said you have the 0 squared plus the 0 squared and all that, then then minus no after equals, then n out of m plus n.
This.
The next one, n out of m plus n. Yeah, that's confusing me.
Okay. So let me first erase these marks I've made. So this right here is exactly that. You realize that there are m zeros. The question tells us there are m zeros and n ones. Now, each of those terms I've decided to square it because that's what we do when we're calculating the variance. You get xi squared. So each of those terms, you square them. Now, when you square the zeros, remember they're m zeros, their sum is not going to give us anything because 0 squared is 0 and 0 plus 0 is 0. When you square the ones, how many are they? There are n of them. Yeah. So you'll have n times 1 squared, which is n times 1, which is n. I hope so. The sum of all those things in the numerator there is n. I hope that's clear.
Yeah, it's clear.
Okay. Any other questions on this question? Or I think we can move to the next bit. Numbers have dropped a bit. So let's move to question 2. Question 2 is a simple one. We're being asked to calculate the mean length of time. And for those who are familiar with this kind of statistics, I think we should all be familiar. Mean should be summation fx divided by summation f. So in this case, we're being given frequency density, but frequency density and frequency can be used interchangeably in these equations. So it shouldn't affect the way you actually work this out. So we can have a small frequency distribution table where we have the class, we have x, we have f, and then fx. So here we have 50 to 53. Notice that the class widths are, like the class intervals are different. We have uneven intervals if you look at them. And here you get the average of the two boundaries. So this is 51.5. This is 54.5. This is 57.5. And this is 63.5. Please, if I make any mistakes in any calculation, please just let me know. This is 5. This is 13. 7.5. This is 1.5. And then you multiply all these. Yeah. Let me just do that. 51.5 times 5, that should give us 257.5. 54.5 times 13, that's 708.5. 57.5 times 7.5 is 431.25. And then 63.5 times 1.5 is 95.25. Yeah, so when you add all these up, so you want to get summation f, and this is 27. And you also want to get the summation of fx, which is I think 1,400. 92.5. Yeah, so that means this should be 1492.5 divided by 27, which actually comes to, wait, is this it? Yeah, this is it. Which actually comes to 995 over 18, which is 55 and 5 over 18, if you like the exact answer, but 4 decimal places, this is 55.2778. That should be your mean length of time. Of course, this is in minutes, so you should include the units. Okay. Any questions there? I think this is pretty straightforward. I'll just hand over to the next presenter.
Yeah, the next question in statistics, it's about price index, and it's saying the table below. The table below shows the prices of flour and eggs in 1990 and in 2000. And that's what the table looks like. If you have not yet studied this, this question in particular is pretty simple. Because they want a simple aggregate price index, it's given by the simple aggregate price index is given by a formula, the sum of prices in the new year or the current year divided by the sum of prices in the base year. And since they have told us to take 1990 as our base year, we are going to sum up the prices from 1990, and that is 3,000 and the 5,000, and that's what will give us. I would love to know if you can hear me at least, or you can see my screen.
Yep.
Okay.
Yes.
Okay. Yeah. So now the prices in our base year are 3,000 and 5,000. The prices in our current year is 5,400 and 7,800. Price index is simply a ratio that is going to help you to see how the prices have changed, over the years. And that is simply why we do that. So we are going to sum up the prices, and we shall have 5,400 plus 7,800 over 3,000 plus 5,000. And that gives us about that gives us about 1.65. But if they want it in percentage, you can have 165%. Yes, Mark.
I just thought we had to multiply by 100 somewhere.
Oh yeah. Yeah, you have to multiply by 100 if you want it in percentage, but it could be asked for as a ratio. Yeah, but then you can have that aside.
So in other words, so every time you're getting these indexes, it's not that you have to multiply by is it that we don't always have to multiply by 100?
if it's depends depending on the person who taught you. Most of them prefer you multiply by 100, but again, you may take it as this. So okay, really, let's just take it as multiply by 100, because if that's what you know, then that's what you should do.
Yeah, usually we multiply by 100, then the answer we get, we say that increased by either increased or reduced depending on 100.
Yeah. So this one increased by 65%. Yes, Marty.
So how would you say that there's a difference between it being a ratio and then it being expressed as a percentage? When would the question set it to be that your answer has to be a ratio, and when would it have to be a percentage?
I imagine the question can be phrased, in a way that it would ask you for a ratio. I may not have the exact words that they could use, but again, a ratio is also a percentage. So I don't think it would be that hard to understand. But since many of you have been taught to use times multiply by 100, then you can carry that on and express them as percentages. I don't know if I answered your question.
Yeah, thank you.
Kali. If then there's no other question, let's go to the next number, because this number is just straightforward in that way. Yeah. Number 5 is a table, shows the percentage of sand Y in soil at depth X in centimeters. Yeah, X is representing soil depth, Y is representing the percentages, and they want us to calculate the rank correlation between these two variables. I hope most of us have covered rank correlation, but if not, it's really easy. So we are going to reconstruct our table, and we are going to have the values of X and the values of Y in columns, and then we are going to rank them. So one of the columns is going to have rank of X, another one is going to have the rank of Y. So the rank of X, we're going to rank them in descending order. That means starting from the biggest. So I see 90 for X is the first one, then 75, then 65, then 60, which is the fourth, and then 55, then 51, and then we shall have 45, and then we shall have 35, and then we shall have 25, and then 20. And then we shall also rank the values in the column of Y in that same way. 92 will come first. Sorry, 96. 96, then 92, then 86. 86, I'm saying two values of 86. There is this one. There is hold on a bit. I'll share the screen one more time. Yeah, I hope you can see the screen now. Yeah, so we had ranked these ones. I beg your pardon to run through this very, very fast. Yeah, so we had 90 as the first, 75 as the second, and then 65 as our third, 60 as our fourth, 55 as our fifth, and then
51.
51 as our sixth, then 45 as our seventh, and then 35 as our eighth, then 25 as 9, then 20 as 10. Then we are going to rank the ones for Y as well. We have 96 as our first, 92 as our second. And again, I was saying that on Y we have two values of 86, which would take on the third and the fourth position. So we are going to average the sum of the two, and that is 7, and that means we shall have 3.5, 3.5. So 86 and 8, the two values of 86 will take on 3.5 as their ranks. And then the next position would be the fifth. So we're going to look for 84, which is the fifth. Then we shall go to 79, which is the sixth. Then we shall go to 77, which is the seventh. Then we shall go to 70, sorry, 70, which is the eighth. We shall go to 68, which is the ninth, and then 58, which is the 10th. Then our next column is going to have the difference between the ranks. So we shall take the difference between the rank in X and the rank in Y. So we shall have 8 minus 3.5, that's about 4.5. Then 3 minus 8, that's -5. Then this is a 0, this is a 7, 1, -7, 9, -9. This is 2.5. Then we have -3. Then next we are going to take the squares of the difference. And then here we shall have 4.5 squared, which is 20.25. -5 squared is 25. This is a 0, 49, 1, 49, 81, 81. Then 2.5 squared is 6.25. Shall have 6.25. And then 9 here. Then next thing we are going to do is we are going to sum up the values of b squared and get summation d squared, because it's what you're going to use to get our rank correlation coefficient, which is given by 1 minus 6 times the summation of d squared divided by n into n squared minus 1. N squared minus 1. So our summation of d squared, you can help me just check that. It is I have 321.5. So that means our rank correlation coefficient is 1 minus 6 times 321.5 divided by n, which is the number of pairs, and we have 10. So it is 10 into 10 squared minus 1. So that gives us I have negative 0.948. You can help me check that if that's what you have as well. I don't know if we have that.
Yeah, I have the same answer.
Yeah, it's the same.
I don't know. I'll just take it as I think we have. I think that would be the answer. So our comment would be there is a negative correlation of this at 5% significance. Of course, you can get this value from the tables, the logarithmic tables, the logbook. Yeah, if there are no questions on this, then I would love to invite our next presenter. Yeah. Which 6 are you talking about? If you're talking about this Infinix X6528, if you're talking about the 6 in the formula, then it is that's the formula for getting the coefficient. Yeah, it's not anywhere in there. Yeah. Delivered, you sent me a message privately. Hello, can you please do an example where weights aren't given directly, but when we are required to calculate weighted aggregate price index? Okay, I think we shall do that at the end. Let me first let my next presenter come through and present as well. Thank you.
All right, thank you very much, Harvey. We shall go to question 5. Let me share my screen. Yeah, it's from statistics. Okay. And it reads, the table below shows the frequency distribution of marks obtained in paper 2 of mathematics contest by a certain school. I've been given a table of marks. It's having those classes and then marks and different frequencies. And we want us to calculate the mean, standard deviation, and number of students who scored above 54%. Yeah, so this is a typical section B question. Usually these ones are quite engaging. Like you spend a lot of time compared to the time you would spend doing the other paper 2 topics, mechanics, numerical methods. So yeah. Okay, now to answer this question, we are not drawing anything. We are just calculating those whatever central tendency measures, mean, standard deviation, and then number of students who got above a certain mark. Yeah, so we shall start by, we know to get the mean, we need to have f of x, we need to have f of x squared. We need to, we use class boundary somewhere, class width. So we shall start by doing that. Yeah, we shall start by getting those various values. You also need the cumulative frequency for part C, where we have to get the number of students who scored above a certain mark. So we shall draw a table having all those columns. Okay, it may not be as neat because we are chasing time. So we have the classes. Allow me to close the chat. If you have a question, you ask that you just unmute and ask because I may not be able to read what is in the chat. Yeah. So we shall have a column for the class, which was given. We have 10, 2, then 22, then 30, 40, 50, 60, 70, and then 82, 90. Then we have a column for frequency, 18, 34, 58, 42, 24, 10, 6, and 8. And we can get the total, the summation of F. If we sum up those, no, shall we need it? Yes, we shall, to get the mean. If you sum up those values, let me use my calculator here. 18, 34, 58, 32. Yeah, it gives me a total of 200. Then we have we shall also need X. We shall need F of X. And F of X squared, we shall need summation of F of X. Then F of X squared. Let me just put here some. So we got as 200, then we have F of X. We shall need the cumulative frequency. I can use capital F to denote it. And then we also need the class boundaries. Yeah, so for the class boundaries, I will first get the class boundaries because it's from the class boundaries that I'll get my X value. Yeah, so when I look at my last class, it's 80 to 90. I don't know any other class width, so I'll just use this 80 for the class before the last one, and I will just carry that 80 and put it here where I have 70. Okay, we have 10, 2, then 22, then 32, 42, then 50, 60, 70, then 80. Yeah, so I think you can say that class width is what? Is 11. Because from 10 we go to 20, then 20 to 30, 30 to 40, 52. So we shall just keep using the same what? Shall maintain it. Yeah, so the last class is having 80 to 90. So I'll carry the lower class boundary of the last class and make it the upper class boundary of the previous class. So I'll put here 80, then 60. I'll put here 70, then 60 here, 50 here, 40, then 30, then 20. Those are my class boundaries. Yeah, then the X value for the first class, I'll get the average of the class bound 10 plus 20 divided by 2, which gives me 15. Then 20 plus 30, 50 divided by 2, 25. This is 35. This is 45. This is 55. This is 65. This is 75. This is 85. Yeah, then summation of, sorry, f of X, I'll multiply F times X. 18 times 15 to give us 270. It's just multiplication. Then I can still go ahead and get F of X squared before going to the next value of F of X. I'll just multiply that 270 by 15 to get my F of X squared at once. So I'll end up with 450. Then from the next one is 34 times 25, which gives me 850. Then times 25, I get 21250. Okay, I'll just fill that table at once. I already have my values here. I'll just fill them in at once, just basic multiplication, so that we save time. This is 850 to 2030, then 1890, 1320, 650, 450, then 680. And when I sum up those, I'll end up with 8,140 as my summation of fx. Then fx squared, I have those, then 71050, then 85050, then 72600. You have to be very careful while multiplying these, while doing the multiplication, because anything small will put you off. And it will be a cascade effect. It may end up being a cascade effect. You fail part A, it follows you up to the last part. So we end up with 387,800 as a summation of f of x squared. Okay. I don't know when this message was sent. Someone has a question, you can ask. Yeah, then for
Yes,
cumulative frequency, yes?
I had a question. I was asking, like, for the class boundaries, would it be okay for me to say, like, 10 to, and then I use the inequality symbol of 10 to less than 20?
10 to, I'm not sure about that. Kalzi, I haven't interacted with that before.
I think it's okay. It's of no consequence really in this
Okay,
particular
thank you.
case. So there's no problem.
All right.
Thank you.
Okay, so cumulative frequency 18, then plus 34. I have 52, then 52 plus 35, 110. We all know how to get cumulative frequency. So let me just fill in 152, then 176, 186, 192, and lastly 200. Okay, so min mark. So we know the formula for getting the mean: summation of f of x divided by summation of f. So summation of fx is 8140, and then summation of f is 200. What's the answer?
$40.7.
40.7, thank you. The marks were in percentages, so you can put a percent. Okay, then we go to standard deviation. Standard deviation. We have a formula for standard deviation, which is a square root of variance, is square root of summation of fx squared out of summation f minus the mean, but squared. So when I substitute, I'll have square root of summation of fx squared, which is 387800, out of some other out of frequency, which was 200, minus the mean, which we got as 40.7, but squared. Yeah. So what are we getting? Two eight two 282.51, all right? 282.51.
Two 282.51.
As the standard deviation. Okay, thank you.
I don't think the root was gotten.
So it's this under the root.
Yeah.
Okay. And it is 16 point?
Yeah, 16.81.
Okay.
But
That's us. Yes?
for DP, if we had to take 4 decimal places, it would have been 8080.
Okay, the final answer is 80.
Yeah, the final answer. Yeah.
Okay. Okay, thank you. Then Patsy wanted us to find the number of students that scored above 54%. Now, it's usually easier to get this on what is it called, on an ogive cumulative frequency curve, but then this time we've not been told to draw one, so we can use the linear interpolation method. Sorry. Yeah, so if I use these upper class boundaries and cumulative frequencies, I will be able to do what? To get I'll be able to, sorry about that, sorry. I'll be able to get the number of students that have scored up to that particular mark of 54 by using linear interpolation. What do I mean? This 152, if I'm to use 152, this 152 here represents the number of students that scored 50 and below. The 120 here, the cumulative frequency of 120, represents the number of students that scored 40 marks and below. 192 represents the number of students that scored 80% and below. So I can use that concept, linear interpolation, to help me get the number of students that scored 54 marks and below first. So I can start by getting the number of students that scored 54% and below. And then you can use that answer to help us get the number of students that scored above 54%. So by linear interpolation, I hope we've studied linear interpolation. The I6 says on the call. I'll use the upper class boundaries and cumulative frequencies. Says Patsy. So 54 lies between, we look for the position where there is the two upper class boundaries between which 54 lies. So these are upper class boundaries, and these are number of students. Yeah, so 54 lies between 50 and 60. So we have 50 here and 60 here. So the cumulative frequency corresponding to 50 is 152. 52. Then the cumulative frequency corresponding to 60 is 176. So I'm looking for the cumulative frequency corresponding to 54. I can call it Y. So I'm going to use linear interpolation to help us get the value of Y. So Y minus 152 out of 54 minus 50 will be equal to 176 minus 152 out of 60 minus 50. Or what are we getting as our Y value?
$2.4.
What are you getting?
2.4.
2.4.
Oh, sorry. I was working out one side. Sorry.
It has to be between 152 and 176. The 2.4 has got by working out just the right-hand side. Yeah. Yeah, so if you multiply and everything, I'm seeing a 166.4 in the chart. Is it the answer? $161.6. We have two answers, so which one is correct?
I also have 161.6.
Okay, since two people have that, we can take that. So 161.6. So that okay, yeah, 161.6. Thank you. So that 161.6 is the cumulative frequency corresponding to 54. So it means that 161.6 students scored 54% and below. 54% and below. But we're interested in the number of students that scored above 54%. So we shall get, so number of students that scored above 54% would be equal to the total number of students, which was 200 minus 161.6. That is giving me 38.4. 38.6. 0.4. 0.4, yeah. And if we round off, because we can't have 0.4 students, we shall have 38 students. As the number of students that got above 54%. Yeah, so that is it for that question. Or alternatively, we could have there's that formula we used to get the quartiles, percentiles, median, and yeah, all those values. We could use that. I don't know if I can quote it here. I've forgotten. Is it L1 plus now instead of putting median, we could put the what? What is it called? The y value, in this case, it would be the y value. Y then minus the cumulative frequency before that class, having the y value, then out of our F1, then times C being equal to our 54. So once you do that, you get a certain value. Then you take 200 minus that value. But I find linear interpolation easier. Yeah, so that is it for that question, and I think it was our very last one. Anyone with a question? Okay, I think that is it.
Matty, looks like Matty has a question.
Yes, Matty. I couldn't see the hand. Matty, you can ask your question.
So I wanted to ask that you know how we're looking at the class boundaries, and though we determined from the 80-90 that you're dropping back the 80 becoming the upper class boundary of the 70. And I think from O level, there was some method that was introduced to me in my stream of 0.5 times 10 power. Was it negative n to be able to know power n, sorry, to be able to know the class boundaries. And then I came to A level, and then I just got confused on how to know class boundaries. Something about the different groupings of data, I don't get it.
Yeah, so there are various. Let me see if I can open my textbook here. You can be given data of different sets. Now, assuming we had been given, like the previous question, the one Jonathan did, 10 to 15, then maybe 20 to 30, and so on. That's where the 0.5 thing would come in, minus 0.5 plus 0.5 to get the boundaries. But for this case, that's how we, let me first say something here.
Excuse me, Kitty.
Yes?
I just wanted maybe to add on to what you're saying to Matty. Yeah, in the example that we have, these boundaries, you realize that there is continuity because the previous boundary, the upper limit of the previous class becomes the lower boundary for the next class. But so there is continuity in this case. You move from 10 to 20, 20 to 30, then 30 to 40. But in the other examples of 10 to 15, then you have 16 to maybe 19, then 20 to 21. There is no continuity. There is as if you've closed the classes. So to bring in the aspect of continuity, you bring in the n correction, which the 0.5 x times 10 to the power n, where n represents the number of DPs. You're doing that because you want to establish continuity. I think maybe that could be the reason.
Actually, that's a better explanation. Yeah, so I think you guys are the same case for all these examples. When you look at question 5 here, they just see the same thing. Like example 5, then the previous question here, it is the same, the same thing that was done.
Thank you.
Yeah, thank you very much, Mark. That's clarification. All right. Maybe we shall go back to, I'll hand over to Jonathan. for his remarks. We shall see what comes next.
Okay, yeah. Thank you once again for coming for this seminar. I've come to the end. We've come to the end of the seminar. I hope you benefited. Yeah, like I said, there's a feedback form. That's feedback form. I'm just going to drop it right now in the chat. It's right there. Yeah, please let us know what you think so that we can make these seminars better for you and so that you can benefit more. Also, the recording of this will be available on the YouTube channel. So feel free to check out the channel as well, subscribe. We also have some content there on other topics, so feel free to check that out.